Okay, we're going to look at an example on how to calculate the correlation coefficient manually. So this example looks at the bivariate data of computer time in hours and the number of likes that have been added over the period of time. So the first thing that you do, you can use your scientific calculator and in the stats mode to calculate your mean for your dependent and independent variable. So we calculate the mean for the two variables and we also calculate the standard deviation for both of them. So when we do that calculation, what we get is for your mean, so let me just label over there that's our x and y, which would be the independent and dependent variable. So our mean is 4.67 for the computer time. For the mean for number of likes is 52.3. The standard deviation is 3.98 and the standard deviation for y is 34.77. Now I've already created a table. Now in the table what you need is all the variables of your x and y variables. Again, in this column we basically just substitute the values that we got. Now remember, xi means your first value, okay? So how we calculate that is for the first column. I'll just make this a bit bigger so that I can show the working out for this one. So that will be one takeaway. Remember, that's your mean for your x variable, which is 4.67. And then divide that by your standard deviation for your x variable, which is 3.98. All we do is we just calculate that and we end up getting negative 0.9221. Now the same method is used for each of the values. So basically for the second one, you would go 6 take away 4.67 divided by 3.98. And if I evaluate all of them, I get 0.3342, negative 0.1683, 1.8417. And if I calculate all of them, as you can see, these are the values that you can get. The same process is used for your y variable. So your first value of y is 24. So we take the 24, take away the mean for y, which is 52.3, and divide that by the standard deviation for y, which is 34.77. What we get is negative 0.8139. Using the same method, for the second value, it's 40, take away 52.3, the total divided by 34.77, and we get negative 0.3538. Same process for the next few, negative 0.0661, 1.9471, and negative 0.6414. So now what we've got is we've got these two values, and these two values, as we know, we need to find what the sum of the product of they are for our formula of the correlation coefficient. Okay, so now what we do is, we take these values and we multiply them together. Basically, we're substituting it into that. So we will have negative 0.9221 multiplied by negative 0.8139, and that gives me 0.7505. The same is done for all of them. Now you don't have to show all of that working for each column, but I've done it for the first one so you know what the process is. So I'll just finish filling in the rest of the table. And we just fill in the rest of it, do the same process, multiply these two values, multiply them together, we get our total. once we get that, all we do is then we just take these totals and add them up. And that gives us the sum of the product of the two, which gives us 4.6874. Okay, now as we know, this is the value that we need in the formula. Okay, all we do right now is just slot this in. So let's write down our formula for R, which is 1 over n take away 1, sum multiplied by the sum of our I values from 1 to n. Okay, and all we do is we substitute now. Now remember, n is the number, how many data values we had. So if you look back to the original question, there's 1, 2, 3, 4, 5, 6. So what that becomes is 1 over 6 take away 1 multiplied by, now all of that, the total of all of that was 4.6874. So 4.6874. And if you evaluate that, remember that becomes 1/5. We get 0.9375. So the correlation coefficient of 0.9375 means that there is a strong positive correlation.